because there's no homework for this section. So I'd rather we try one now, if you don't mind. Okay. All right, everyone, I'm sure you're still working. I just wanted to point out that you start with your position. You definitely want to calculate your velocity and your acceleration by taking derivatives. And then I decided to figure out when the velocity is equal to 0. So I set the velocity equal to 0 because I really want to create a couple of graphs. I wanted to create one graph of the velocity, and I wanted to create another graph of the acceleration. For your acceleration, so this is velocity here. The acceleration graph is not going to be interesting. So for the acceleration graph, the acceleration is always positive if you don't allow negative time. So anytime you put a positive number, is going to be positive. So what we really need to do is we need to figure out what the signs of these two velocities are. What's the velocity from here to here? What's the velocity from here to here? And I guess the easiest way to check that is by using a test point. I know that I had showed you using factors, signs of factors before. Another way you could do it is just by plugging in a test point into the velocity. So you want to make sure that you plug in a number on this side. So what would a good number to choose be? Maybe we could choose something like 1/2. I think rad 8/3 is bigger than 1/2. So let's try plugging in a 1/2. So when I take v of 1/2, what am I going to get? I'm going to get 3/4 minus 8. And that's going to give me a negative number. So what that means is that my velocity is negative on this part. I can choose a number like 3. If I have v of 3, that's going to give me 27 minus 8. That's greater than 0. So the velocity is positive on this side. So now that I have these two graphs, I can compare the signs to answer this question. So I'll give you a couple moments to finish up your thoughts about this, and then we'll discuss the answers in a second. Ken, if you can hear me, 1 is actually to the left of the square root of 8/3. So just so you know. The square root of 8/3 is 1.633. So that's not, maybe I wrote it so it doesn't look right. Hold on. It's the whole thing is under the square root. It's like this. All right, I hope we're ready to discuss this now. So let's take a look at each of these pieces. So part A says, determine the direction the train is traveling when S of t is equal to 0. So I guess the first thing we need to figure out is we need to figure out for part A, we need to figure out when is S of t equal to 0. So I'm going to take my position function, t cubed minus 8t, I set that equal to 0, and I factor out a t, I get t squared minus 8 equal to 0. This tells me that t is equal to 0 and t is equal to plus or minus rad 8. Right? Maybe you could write this as a difference of 2 squared, so it's like t times t plus rad 8, t minus rad 8, if you wanted to factor it. So now I need to calculate the velocity at each of these points. We don't allow negative time, so we're just going to make that positive rad 8. Okay, no negative time. Then we just plug into our velocity function. So v of 0 is equal to 0 minus 8. That's equal to negative 8. So it's going west because positive is east. And when I plug in v of rad 8, that's going to give me 3 times rad 8 squared minus 8. That's going to be equal to 24 minus 8, which is, I really only care about the sign, but that's 16. That's greater than 0. So this means it's going east. So let me move this slightly. So I want to emphasize that this number is less than 0. So that means we're going west. Is there any questions? So part of the time it's going east, part of the time it's going west. Great. Then the next part is what part B says. Determine the direction the train is traveling when the acceleration is equal to 0. So for part B, the acceleration is equal to 0. That means time is equal to 0. So that means 6t is equal to 0, which means your time is equal to 0. So we already just calculated that, right? When the time is equal to 0, the direction is west. So this means it's going west. So that's the answer for part B. And then for the last one, for part C, determine the time intervals where the train is slowing down or speeding up. You just got to see when the two signs agree, and when the two signs agree and when the two signs disagree. So for part C, it's speeding up when t is in the interval from rad 8/3 to positive infinity. And it's slowing down when t is in the interval from 0 to rad 8/3. Does that make sense to everybody? So those are our answers here. Okay. All right. Any questions for me?